fact that you're here. On behalf of Ursula and myself, if you don't know Ursula, she's second row, right there in the middle. She's the motivation behind this talk. I'll do the speaking, but she's the one that did a bunch of the research and pushed to have this done, and I'll say more about that at the very end. But on behalf of the entire Richmond Historical Society, we are honored by your presence here. We know that there's other places you could be, other things you could be doing, but we're heartened by the fact that you're interested in the history of this area, and particularly a man by the name of Seth Neddermeyer that by the time I'm done with this talk, I hope you'll realize is the most famous person ever to come out of the city. Now, just a couple of details before I begin. I am not too proud to beg on behalf of the Richmond Historical Society. We have a donation jar over there on the table. There are some items for sale. If you go to a pop concert today or a rock concert today, you usually buy little mementos, a t-shirt or something like that. You have the opportunity to do that tonight. You may not think that Ursula is a pop star, but I'm here to tell you that when people talk about Taylor Swift, Ursula Adamson is usually in the next sentence. So if you don't buy something over here, you'll regret being here without that. So, also there's cookies and water over there. If you find yourself getting a little bit drowsy while I'm talking, and if you want to stand up and pace at the back or go get something to eat and drink, you will not offend me at all. So feel free to do that. I intend to talk about 45 minutes, give or take, and then we'll have some time for Q&A afterwards. But the topic, of course, Seth Neddermeyer. Now, every hero needs a crisis. And the crisis in the life of Seth Neddermeyer occurred on April 21st of 1943. 30 of the world's most intelligent people had been invited, cajoled, forced to participate in some lectures and discussions in a library in a repurposed boys' school in Los Alamos, New Mexico. These 30 men were tasked with developing the world's most powerful explosive. These 30 men were expected to end World War II. These 30 men did change the world. Most of the time in that library, the mood was very boisterous. There was the enthusiasm and confidence of youth. The average age of these 30 people was just 25. Think about that. But this day, the mood was dark. It was depressed. They were discouraged. The older scientists were actually angry. And the reason was the day before, some new data had come in. A physicist by the name of Robert Serber stood in front of that group with a piece of chalk in one hand and the blackboard behind him. And he said, we've gotten some data from a new man-made metal called plutonium. And it shows that that metal is twice, 50% I should say, more radioactive than what we thought it was going to be. They've been working with uranium, and that, they said, is a well-behaved metal. But here's this man, Robert Serber, and he said, the problem is we are not going to be able to assemble a critical mass. Now, for the most part, I'm going to try to stay out of the weeds tonight, but I've got to give you a couple of technical bits of information. Number one is the definition of critical mass. That is the smallest amount of material that you have to sustain a rapid nuclear reaction. For plutonium, it's about a little smaller than an orange. For uranium, it's about the size of a cantaloupe. The problem is that when the neutron came flying into a plutonium nucleus at very high speeds, the nucleus would vibrate a bit like a water-filled balloon and eventually separate into two other elements. In the case of plutonium, it's zirconium and xenon. You're starting to look smarter already. But here's the problem. When that happens, plutonium kicks out 3 new neutrons. That meant this was twice as powerful as uranium and twice as fast as uranium. Those 3 neutrons go look for 3 more nuclei. This is all happening at roughly the speed of light And each one of those will kick out 3 more neutrons. In the next generation, you have 27, and then 81, and then 243, and it just goes exponential from there. Again, all of this happening very, very rapidly. Now, there's one other issue here, and this may be the most complicated thing I say tonight. When you take a proton, one of these red balls, and put it together with a neutron, a blue ball, the weight is more than the sum of its parts. Imagine I have a cantaloupe in one hand that weighs 7 pounds. I have a pumpkin in the other hand that weighs 8 pounds. I put them on the scale, what would I expect to read as far as the weight is concerned? 15 pounds. To the amazement of physicists back in the 1920s, it weighed 20 pounds. Where did that extra mass come from? I'm more concerned about when it goes the other way. You take 20 pounds of cantaloupe and pumpkin off the scales, and you separate them, and you weigh them again, it's 7 and 8 again. Where did that extra 5 pounds go? Well, Albert Einstein answered that with his famous equation, E equals mc squared. He said, when you bring these neutrons and protons together, there's binding energy that keeps them together. And when you split them, that energy is released. It was mass when it's together. It's like glue that holds it together. It's solid. But when you split them, the glue, think about it as vaporizing in the form of energy. And that energy is what prevented them from creating critical mass. The idea was, to make a bomb, you would have a 3-inch diameter naval gun. They cut it down to 6.5 feet long, and they said, we'll take 3 rings of plutonium. Now, this worked brilliantly for uranium. This is the way the bomb worked over Hiroshima. You put explosive behind it, you shove that 3-ring system at a target at the end of the barrel. You can do that fast enough with uranium to create critical mass. Those of you who shoot guns, the maximum velocity they could get back then was 3,150 feet per second. Right? That is not fast enough to get the plutonium together, because when it gets close, the reaction begins to go and it will blow itself apart. Now, you'll have an explosion that'll be worth a few tons of TNT, not 20,000 tons of TNT that they wanted. So what are they going to do? If plutonium doesn't work, let's stay with uranium. We know that's a well-behaved metal. Let's work with that. The problem is they can't make it fast enough. When you dig the uranium out of the ground in the Congo or Canada or Nevada, most of it is U-238. Now that number, 238, 235, that's the total number of protons and neutrons in that atom. Most of it is non-reactive. It's useful, it's very heavy. You use it for weights and you use it for armor-piercing shells and things like that. But if you could enrich this radioactive stuff from 0.7 to 3%, it's very difficult to do, very slow to do. Now you have enough energy to run a nuclear power plant. Fermi 2, south of Detroit, the old Big Rock Point plant up in northern Michigan. Remember that? They put it up there because they had the cooling water in Lake Michigan, and nobody lived up there, so if it blew up, nobody dies. Right? And if you can enrich this stuff to 30%, very time consuming, now the power plant is small enough to fit in a submarine or an aircraft carrier, and you can power those things for months. In fact, there are people from Richmond working on the George Washington aircraft carrier that is just now nuclear power. You can stay out on the water for months. There is no reason to enrich uranium beyond 30%, no medical reason, no scientific reason, except for making a nuclear weapon. And that's why the last 2 to 3 to 4 years, the world began to get nervous when Iran enriched uranium to 40%, to 50%, to 60%. That's the last number you saw in the news, but if the papers I read are correct, 70%. And the world got together, and Israel, of course, the United States, of course, Western Europe, And they quietly said, they won't admit this publicly, if the U.S. wants to go in and destroy 3 nuclear facilities in Iran, we won't say anything. You can fly over our countries. And in June of this year, that's what they did. And they went in and they took out what are called centrifuges. Now, to enrich uranium, you have to turn the uranium into a gas. And you have 238 and 235. They weigh a little bit different. And I don't know how many of you have seen the cream separator over in the barn, but these centrifuges do the same thing that does. They will separate heavier stuff from lighter stuff. But if you've got 238 pounds, 235 pounds, there's not a lot of difference there. So it takes hundreds of these things to do the job. And that's what the U.S. destroyed with those bunker buster bombs. Well, if you've watched the movie Oppenheimer, I don't recommend it, but if you did, several times in the movie you saw Robert Oppenheimer standing in front in that library dropping marbles into a fish bowl and into a wine glass. He actually did that. This is how much uranium you need to make one bomb if you're going to do it out of uranium. This is what you need if you're going to build it out of plutonium. We can't make the uranium fast enough. We can't assemble plutonium. What are we going to do? And Robert Serber, standing in front, and by the way, this is what plutonium looks like. Can you see it's a little bit of a bluish green gray color? That's actually plutonium right there. He said, we've got to come up with a way to do this. And they proposed shooting projectiles at each other. We've already talked about why that won't work. They talked about using pie-shaped segments. And he put all of this in a book, How to Make an Atomic Bomb. Now that book was the one I had. My daughter took it and refuses to give it back. That was the hardcover version. I have the paperback version right here. If you want to know how to make an atomic bomb, it's right here. This is written by Serber. And he turned on Neddermeyer later in their lives, sadly. But anyway, at this point, they're baffled. It turned into a bit of a shouting match. These are 30 of the world's most intelligent people yelling at each other. But at that point, a 35-year-old man, physicist, world famous, in the back of the room stood up. In the Oppenheimer movie, this is how he's portrayed, but the people who were there said he stood. Seth Neddermeyer. And he said, the data came in yesterday, all night long I've been working on calculations. And I have a proposal. We can take a hollow sphere of plutonium, surround it with explosives, and crush it very quickly and create a critical mass. Now, every hero faces opposition. And the opposition in this case to his proposed model, here would be the plutonium, the explosives around it. It was severe. Hans Bethe, a Hungarian physicist, he would later go on to win a Nobel Prize. He was the most polite of the group. He said, it's not likely to work. Robert Oppenheimer, he's in charge of the whole project. He got quite angry. And he said the plutonium is going to turn to liquid when the reaction goes, and it'll squirt out all over everywhere. One person, I don't know if this is true or not, one person said that he took a pitcher of water, cupped his hand, poured some water in the hand, took the other hand and crushed it. The water comes squirting out. That's what's going to happen to your plutonium. He yelled at Oppenheimer. The youngest one of the youngest, Richard Feynman, he went on to win a Nobel Prize. He was the party boy of the group, the jokester. He had a great sense of humor. He died in 1988, same year that Neddermeyer died. He just had two words, but everybody listened to him. It stinks. And the argument went on. But Neddermeyer stood his ground. He said, no, let me explain clearly. Now, this is going to be important later. He was very articulate in explaining why he thought his proposal would work. He reviewed his calculations, very deep math. And remember that thought, articulate, all right? But the question is, why did they give him the respect that they did? Because after about 40 minutes of argument, Oppenheimer said, enough. Neddermeyer, we're going to put you in charge of a new group. It's going to be called the E5 group, the 5th group in the explosives division. You're going to report to Captain William Parsons of the Army. He's got the E group. There's E1, E2, E3, E4. We're going to create E5. We'll give you 15 scientists. You take them and some technicians, go out into the desert with your explosives, and you see if you can crush metal uniformly. Why did they allow him to do that? What led to that point? It begins here in Richmond. This is where he was born. He grew, he was educated, he graduated from Richmond High School in 1925. His grandfather, you're not going to be able to read the words on the left here, the bulb is not very bright, and the screen maybe isn't big enough, but Henry Neddermeyer, born in Hanover, Germany. And you can see the date, 1827. He met a lady by the name of Marie Neumann, they married. And if you know your European history from about 1850 on, continental Europe was plagued by political instability, economic problems, and increasing religious persecution. Those 3 factors fueled the largest human migration in history. 9 million Europeans moved to the United States. Prior to 1890, it was each individual state that regulated how many people could come in. Michigan welcomed the Neddermeyer family with open arms. They settled in Ira Township. And we have a lady that descends from that family, sitting right next to Ursula. And the 2 of them, Henry and Marie, in Ira Township, had 13 children. If you're young enough, maybe that'll motivate some of you. Down the list is a man by the name of Ferdinand Neddermeyer. And when he became an adult, he moved to Armada. We have some people from Armada in the back here, and yes, thank you. And he set up a shop with a partner, a store. And while he was there, he met a young lady by the name of Mary Emily Lathrop. Those of you from Armada know there's a Lathrop Street there, named after that family. Mary Emily liked Ferdinand. Mary Emily's dad, how can you remember all these names? It's going to get impossible. But Mary Emily's dad had a grocery store in Armada. But Ferdinand and Mary Emily liked each other. They got married. And the store was doing okay in Armada, but they decided to close it down and move to the bigger town of Richmond and set up a store there. And when they did, they had 4 children, and they lived in a house on Ridge Street that still stands to this day. Don't hold me to this number, but it's about 11 houses west of Main Street on Ridge Street, which becomes Armada Ridge. And if you walk on the sidewalk in front of that house and you look at the sidewalk that comes out of the porch, you'll see Neddermeyer stamped in the concrete. That's where he grew up. And by all accounts, Seth's, as well as everybody else that I've been able to read, said that they had a very happy family life. Gail was the oldest one. Seth was number 2. Pauline, number 3. Rebecca was the baby. And there's the house. And again, happy memories at that point. Neddermeyer, you can't see this where you're sitting, but it says the Neddermeyer Company. This picture was taken at the grand opening of that store. This is the Gert block. Gert Shoes is right there. Richmond Relics, right there. This lighter area, a little bit above it, is covered over with black. I don't know if it's aluminum or steel or vinyl, but it covers that sign right there that says the Neddermeyer Company. Now, what influenced Neddermeyer? He, in a long interview given 4 years before he died, said his parents encouraged him to read widely while he was still in school. And then he says, teachers made a difference. How many of you here are or have been a teacher? Quite a few. And I don't know if we realize how powerful teachers are. Sometimes just a word, a conversation, if you'll forgive a personal illustration, a 5-minute conversation with a physics professor that I had changed my life. I had just started college. I changed my path completely. 5 minutes was all it took. And that's what happened here. The first influence that Neddermeyer refers to is a man by the name of Andrew Beam. He was a World War I veteran. He taught science. He was interested in science. He was also a football coach, but he said, not your typical football coach. He said that most coaches would be yellers. Yelling at the kids, come on, we're going to get out there, we're going to win this game, or we're going to die trying. Lose is not an argument. You've heard all the speeches, right? You've seen them on television. This guy was, guys, thanks for showing up tonight. We've got a game, and really appreciate you being here. Let's go out and give it our best. And you know what? If we win, wouldn't that be great? And if we don't, well, we give it a good try. That's the way he was. And but he and Seth Neddermeyer, I'm guessing, spent 3 evenings putting together and testing a little circuit board that was the equivalent of an AM radio. I don't know how many of you have done that, but it's quite simple to do. Some of you have. Just some simple electronics, and you got what would look like a fractured piece of silicon. You could take a needle and put it on different places there, and you can listen to WJR and WWJ, and that's what he did. And just a simple thing, and yet it influenced him. A bigger influence was a teacher by the name of Wilfred Trudgeon. He was from the Upper Peninsula originally, and Seth Neddermeyer at the end of his life said that he influenced me. But he said not only in science, but he got me to think about the bigger issues of life. He said Trudgeon was just a decent human being. He taught me to think about culture, about societal issues, about labor management issues, about international relationships and things like that. And it broadened his perspective. Coming out of the yearbook that some of the people have put together over in the museum here, this is where Ursula had a huge part, all of this that I've been talking about. The senior class officer, Seth Neddermeyer, is president. That implies that he probably was well liked. He probably was willing to assume responsibility. Now, one other thing that is quite striking to me. Oh, by the way, those of you from Richmond, can you read that? Weeks beat processing? Fruin Buick. So, names that are familiar in Richmond. This intrigued me. Neddermeyer was a good student. He was not a brilliant student. Notice, he's salutatorian, not valedictorian. That surprised me a little bit. The other thing, and remember I said he was able to articulate his position on the plutonium very well. Notice he took a class on rhetoric. He was part of the debating team. And if there were students here, everybody's graduated as far as I can tell. Oh no, there's at least one back there. That's something to think about. If you want to be a success, I don't care whether it's science or math or accounting or insurance or financial stuff or social studies or history, you've got to be able to communicate. And Seth Neddermeyer benefited, I assume, from these classes. Well, he graduated, as I said, in 1925. He went off to college, originally at Olivet College. He said that was the family college. His mother graduated from there. His older sister graduated from there. He spent 2 years there. And at that point, they moved to California. Now, there's a couple of reasons for that. I don't know which one of these is more important. I think the first. In the interview that Neddermeyer did 4 years before his death, he said that when people began to buy cars, they could drive into Detroit. The selection of merchandise in Detroit was much greater than it was in the Neddermeyer store. And so sales began to drop. The other thing, Ferdinand Neddermeyer, Seth's dad, became interested in the nursery business. Plants, trees, fruit, vegetables, that sort of thing. And the headquarters of that was California. Seth wanted to study under the best and brightest, and he began to read when he was a senior in high school about something called cosmic radiation. The radiation that comes into the earth from outer space, the stars. And the best people were at Stanford and, more importantly, Caltech. So he got his bachelor's degree at Stanford University, and then for graduate school moved to Caltech. Now, he wanted to be the best. And so he made a conscious decision at the end of his first year at Olivet to be around the best and the brightest. And so when he went to Olivet, he got in touch with a man by the name of Eugene Skinner. He was interested in dentistry, particularly dental materials. In fact, later he wrote a book on what we would call amalgams and porcelains and gold for dental applications. He later became Dean of Dentistry at Northwestern University, Big Ten School. And so a top guy. More importantly, when he got to Caltech, he went and said hi to a guy by the name of Robert Millikan. Now, there's a lot of names here. This is not one that's necessary to remember, but Robert Millikan won a Nobel Prize in 1923 for some work on nuclear issues. When you win the Nobel Prize in physics, the world is telling you you're the smartest guy in the world. That's Millikan. He hung out with Albert Einstein. He got a $40,000 check from the President of the United States. This is Millikan and his wife. Today, you win the Nobel Prize in physics, you get $1.3 million. If you win the Nobel Prize, the Peace Prize, that's more political, you get a $3 million check. I'm a little bit bothered by that. It seems to be physics is more important. But Millikan, a top guy, and then the most important man, and this guy you need to remember for the next 20 minutes, Carl Anderson, just 2 years older than Seth Neddermeyer, but a professor at Caltech. And he did cosmic radiation research. And Neddermeyer wanted to do that. That was his fascination. And those two guys, this is Anderson when he's older, Anderson when he's younger, they discovered, Anderson got most credit for this, the positron. That's like the electron, which has a negative charge. The positron has a positive charge. I'll come back to that in just a moment. They did that in 1932 working together. And then in 1936, with Neddermeyer doing 90% of the work, they discovered the muon. Now you're tempted to say, who cares? All right, what difference does that make? I hope to convince you that it does matter in just a little bit. But before I do, this is the catalog from Caltech, 1941. All right, look at the people who were professors. Carl Anderson, I've talked about. Harry Bateman, I wish I had time to talk about. He was a mathematician that influenced Neddermeyer quite a bit. Robert Millikan, I've talked about. Robert Oppenheimer, professor, theoretical physics. He was like Einstein, sat at the desk and did calculations. A man by the name of Richard Tolman. He was one of the 30, along with Oppenheimer, in that library. And I don't want to be too crude here, but one of the reasons I don't care for the movie Oppenheimer is because they show Oppenheimer having an affair with this guy's wife. Yeah. And whether or not that happened is debatable. So a lot of people think it did. They certainly were close emotionally. And when Richard Tolman died, much later, his widow and Oppenheimer were close friends for the rest of their lives. But, graduate students, all of these people did something significant. But Neddermeyer, the most famous of the bunch. Now, I said Neddermeyer's career took off when he started working with Anderson. Number one, they discovered the positron. It's not easy to do. It turned the world upside down when they did it. It's the first discovery of antimatter. This endeared Neddermeyer to Oppenheimer because Oppenheimer, sitting at his desk, theorized that antimatter has to exist. Nobody had found it. To this day, we don't know where most of it is. It's out there somewhere. We just don't know where. It has to be out there. But still you say, well, what difference? Well, if you ever have cancer, you'll be happy Seth Neddermeyer lived. Because the PET scan, have you ever heard of that? Positron emission tomography. This is what a PET scan looks like. You can clearly see your organs. You can see if there's anything messed up with your organs. It just shows up so well with a PET scan. And there's radiation therapy you can do with it. There's other things you can do with it that maybe are a little bit too complicated to go over. But it made Anderson famous. Again, he won the Nobel Prize for that. And then they discovered the muon. Now, again, you say, big deal. All right? If you're Indiana Jones and you want to see inside a pyramid and there's no door and you don't want to destroy the thing to see if there's a mummy inside or some gold or anything like that, artifacts, well, you can shoot it with muon tomography. And you can see exactly what's inside that pyramid. Maybe more importantly to this area, I don't know how many of you are aware that the Sarnia-Port Huron border and the Windsor-Detroit border are the most heavily trafficked borders for human trafficking. They also worry that radioactive materials will come across the border. The stuff that we don't want here in the U.S., dirty bombs, a real bomb. And if there's any suspicion whatsoever, I know this is at Port Huron, I assume it's at Detroit, but I don't know that, they can use muon tomography to look at that briefcase, that car, that truck. You can have radioactive material sealed inside of lead, and they'll still see it. It's not a question of maybe, no, they will see it. And this is a little bit different, but this is a semi-truck with a lead box inside. There's a guy standing, a guy sitting. These two guys were guinea pigs. And I'm going to be a little crude here, but they were told this is not going to affect your reproductive organs. It's not going to affect you one bit. You can see where the guy's holding his hands. And that picture was taken at the Port Huron border. I've got a friend that works up there. He's retired now. He used to be FBI, but that came from there. Now I'm going to go through some slides pretty quickly because it would take about 3 hours to make it sensible. But Neddermeyer created what's called a cloud chamber. This is Neddermeyer, this is Carl Anderson. And they decided to do some experiments on top of Pikes Peak. The reason is this cosmic radiation coming in from the stars, when it hits the atmosphere, is scattered and it's mixed with too many oxygen and argon and nitrogen atoms. But if we can get more than 14,000 feet high, the air is thinner, and we can do our experiments. Now think about this. Neddermeyer is 25 years old to 27 years old. They are willing to spend millions of dollars in today's money on his ideas. Not proven. And so they go up there, here's a truck and here's a trailer, his cloud chamber and some other equipment is in here. They built this water tower for cooling because around the cloud chamber you've got these powerful magnets that get very hot. And he was up there for a while. It's always snowy up there. And this isn't going to mean anything to you, but this is what you see when you look into the cloud chamber. It's a glass window about yay big. And when these particles come in from outer space, they get inside this thing and they leave a track. And energized by the magnets, and every one of these things in here that look like scratches to you. But this particular track, highlighted in yellow, it looks no different than any other, but that track made Seth Neddermeyer internationally famous overnight. It turned the world upside down. We don't understand why. It doesn't mean anything to us because we don't understand the implications of it. And but they published this paper, and I'll show you that again. They published several papers. They did several talks. This is a sketch of the radiation coming out of the star and so forth. We don't think it's a big deal, but Europe and Russia got together and they built the Antares laboratory under the Mediterranean Sea off the coast of France. Millions and millions of dollars went into the construction of that thing. The United States set up the Ice Cube Neutrino Telescope under the Antarctic to study muons and what muons could do. all emanating from the work of Seth Neddermeyer. If that isn't enough, they built massive laboratories around the world. Now think, I mean, all of this is just to study muons and use muons as tools. I don't know how many of you have heard of CERN. It's a laboratory in Switzerland on the French border. And in English, the letters would be arranged, but it stands for the European Center for Nuclear Research. All of these buildings built to pursue what Neddermeyer started. Los Alamos. This is a small part of Los Alamos, but you see this long building here? They shoot muons down through here to crack other particles. When we were in school, we were told the atom consists of an electron, a proton, and a neutron. Today, you can crack open the proton and there's a whole other world inside. Pions, muons. Quarks, mesons, W plus, W minus particles, some 26 particles inside the proton. And that is what Neddermeyer began to look at, and that's what made him famous. Now, this slide isn't going to mean anything, and I probably should not have put it in here, but there's the track that made Neddermeyer famous right there. And Rabi, Isaac Rabi, he won a Nobel Prize. He made this famous statement, "Who ordered that?" Now, what I'm going to say probably isn't going to make any sense, right? And like I say, I probably should have taken this slide out, but that has tremendous implications. What he meant, and by the way, this is a slide that I copied from another presentation, this whole thing. I just borrowed it from a guy from Fermilab. This was a talk given in 2014, and talking about Seth Neddermeyer, and this famous statement, when Rabi heard what Neddermeyer had done, he said and wrote, "Who ordered that?" What it means is they now understand the order in the universe. And it would take 3 hours, I suppose, to describe this as well, but we know exactly when Halley's Comet is going to come back. We know exactly when the sun is going to rise tomorrow morning. You have no idea when your next flight to Florida is going to take off. Right? But there's order in the universe. And that was astounding to people that we finally had proof that everything works systematically and logically and follows all of the laws of physics and chemistry and all of that. It has theological implications as well. Rabi was an agnostic. He didn't believe, he wasn't certain there was a God. He didn't believe in a personal God. But what he meant by that was that there has to be an explanation. You know, the French philosopher, why is there something instead of nothing? And there's a movement that's become quite popular about 15 years ago till now called the Intelligent Design Movement. These are scientists, mathematicians, philosophers. There are thousands of them that they may not believe in a personal God, but they say something has to exist to have designed all of this. And it's much more complicated, but that intelligent design movement started back here when Rabi, when he was a much younger man, said, "Who ordered that?" And the guy giving this talk referenced that. Again, it's a philosophically profound statement. This is the way Rabi is portrayed in the movie Oppenheimer. He's the guy that was very angry at dropping the bomb on Japan. He didn't want to do that. He argued with Oppenheimer, and that's a true deal. He said, we can't kill people. Have you ever heard of the trolley problem in ethics? Mm-hmm. That's the issue right there. And do we do it or don't we do it? Well, they went on to publish a bunch of papers. I tried to find one of these. I thought the museum over here ought to have a copy of this. But this is the paper. You can't read it. It's Seth Neddermeyer, Carl Anderson, and I can't even read the title from here, but Note on the Nature of Cosmic Ray Particles. The Physical Review was the physics journal back in Neddermeyer's day. And back then, up until about 2000, when you published a paper in a scientific journal, the journal would send you 50 paper copies of your article. And it's tradition that if somebody wants to give you a compliment, back then it was snail mail, today email, they send you a letter, I would appreciate a copy of your article. Well, they've already got the magazine. Why do they need another copy? Well, again, tradition. You sign it with the compliments of the author and then sign it and send it back. It's a sign of respect and things like that. And somewhere in the United States, there's this magazine that Seth Neddermeyer signed. And, but who knows where it is. Well, let's go back to Los Alamos. Before Neddermeyer got to Los Alamos, at this point in time, he's world famous. In Richmond, nobody knows who he is, but around the world, he's incredibly famous. And so he was told, we need you. The US government came and said, we've got to have you work on, again, these vocabulary things. Photoelectric proximity fuses. What does that mean? If you're in the Army and you're shooting a gun, artillery or machine gun at an airplane that's 2 or 3 miles high and it's a mile downrange, what's the probability of hitting that thing? It's low. They didn't have the electronics, the radar back then. Today is, what part of the airplane do you want me to hit? But back then, no. So what they wanted was for a shell to go up there, and if it got close to the airplane, using photoelectric things, they can tell, it'll explode, and the hope is that some of the shrapnel will damage the airplane. And Neddermeyer did that, and I was quite amused in reading about this. Again, you know, when you stand up front, you're talking about 20% of what you have. And you can go on Amazon, and you can buy a photoelectric proximity sensor. That's Seth Neddermeyer. Well, after that, Robert Oppenheimer, he took a train to Washington and said, Neddermeyer, we need you in Los Alamos. Neddermeyer was one of the first 5 people that Oppenheimer talked to about moving down there. And he relocated, and he became part of William Carson's E-Group, as I said before. He was initially given 15 scientists plus a lot of technicians. In 3 months, that group made a lot of progress in that implosion technique, and Oppenheimer gave him 50 scientists and a lot more technicians. Now, while he was in Los Alamos, he met a lady by the name of Doris Carter. She was what we would call a gopher. She did secretarial work, she ran errands, she did some staff work and things like that. She doesn't look terribly attractive here, but the accounts were that she was quite attractive. And her dad, they came from Mound City, Missouri, owned a grocery store. And I don't know if that's how some of the conversations began, their common interest in merchandising, but they were married on June 10th. Now, try to remember June 1944, that's important in just a second, in Santa Fe, New Mexico. Los Alamos is not far from Santa Fe. They had 2 children. The boy was named Peter, he was a carpenter, and the daughter, Ursula and I have looked into that a little bit without success, but we're not done yet. Skip that. Oh, by the way, this, I don't have time for that. It was not all sunshine and roses. As I said, Neddermeyer made a lot of progress. But in the spring of 1944, they reached a plateau. They couldn't get over the hump. And Oppenheimer was getting nervous. He's the boss. He's in charge of the whole thing. What are we going to do? And he realized, being a theoretician, it was a math problem. And Neddermeyer did not have the math skills to deal with it. And so Oppenheimer said, who's the best math guy in the world? It was a Hungarian by the name of Johnny von Neumann. I can't even say it, Johnny von Neumann. And told him, you get down to Los Alamos. And as soon as he stepped on the complex, Robert Oppenheimer called him into his office, locked the door, and for 3 hours reviewed Neddermeyer's work. And at the end said, is this work worth pursuing, or have we reached a dead end? If we have, all of the work at Los Alamos was useless. And von Neumann said, give me overnight. And he took all the papers that Neddermeyer had written, took them to his room, spent the night reviewing them. The next morning came back and said, this work needs to continue. I can deal with the math. At this point, Neddermeyer's offended that Oppenheimer's going behind his back. Von Neumann and Neddermeyer sort of got along okay, but Neddermeyer's offended. At that point, nobody's getting along with the Army guy. He's very regimented and very structured. Neddermeyer is a little bit on the reserve side. He wants to be all by himself with his scientists and technicians, nobody interfering with what he's doing. You can understand that. He was a little bit reserved, so he didn't talk about these things out loud. The stress would just build up inside and he would explode finally. If you're married with somebody like that, you understand that. You don't talk about things and the resentment just builds. And at that point, Oppenheimer said, enough is enough. And he brought in an American by the name of George Kistiakowsky, who was an explosives expert. And in June of 1944, right near the wedding date, Neddermeyer was fired. Demoted to senior technical advisor, and George Kistiakowsky took over. Now, don't get scared by the math. This is what Neddermeyer did. And how do you compress that plutonium? I'd love to go into more detail here, but those of you involved in explosives, you can probably understand this a little bit. Neddermeyer's idea was, let's build a soccer ball of explosives around a ball of plutonium inside. The sphere of plutonium was about like this. And he said, we'll make these explosive lenses, they're called. And we'll have a detonator on each one. I'll show you a picture of that in a little bit. But when the detonator fires, the shock wave emanates out from here in sort of a conical pattern. And the shock wave, the shortest path to the plutonium in the blue-green is right here. So this part of the plutonium begins to compress while this is still where it is. And Oppenheimer's prediction of it squirting all over the place comes to fruition. And the math, this is what Neddermeyer did. If you were a physics student in high school or college, you would look at that and say, it doesn't look all that complicated. This is in 2 dimensions. The problem was Neddermeyer couldn't do it in 3 dimensions, and that's where von Neumann came in. He did. Needed computers. Very first computers produced, Los Alamos, and so forth. Now, the question is, will it work? The uranium bomb, they didn't even test that thing. They were so sure it would work. No need to test it. Right? But this thing, there's a lot of technology. How do we get all of these detonators to fire at exactly the same time? That was a marvel. There was a brilliant physicist that figured out how to get them all to detonate within 1/1,000,000th of 1 second. And just phenomenal. And they were placing bets. The test was done on the morning of July 16th, 1945. Same day, they were meeting over in Potsdam. Stalin, Truman, Churchill. Truman on the edge of his seat, waiting for the results of this thing. The physicists were there, and they were making bets. Will it be a dud? Will it destroy the entire world when it goes off? What's the probability that it does? And they were betting how many tons of TNT will this thing produce? Isaac Rabi, the guy who said, who ordered that? He won the bet. 20,000 tons of TNT, that was it. And about 1/100th of 1 second after the explosion. And about 3 million degrees Fahrenheit on the inside. And there it is. The sad part, Neddermeyer wasn't there. Kistiakowsky was there, Rabi was there, Oppenheimer was there, Oppenheimer's brother, a lot of other people. But Neddermeyer, demoted, didn't get invited. And to me, it's one of the most unfair things. Again, in any hero's life, there's going to be setbacks. It didn't end badly. In his later years, Neddermeyer went to the University of Washington, Washington State, and was an assistant professor there for the rest of his career. In 1982, Ronald Reagan awarded him the Fermi Prize. Earlier I told you the Nobel Prize is the #1 prize in physics. The Fermi Prize is #2. And because of his work on the positron, the muon, the atomic bomb, the science people around the world said it is so unfair that Neddermeyer was never awarded anything significant. And they convinced Reagan in the Atomic Energy Commission, Department of Energy, to present Neddermeyer with that award. Oppenheimer never won the Nobel Prize. He probably should have for his work on cosmic radiation and theory. But Johnson awarded Oppenheimer the Fermi Prize in 1962. This is the way Neddermeyer's pictured at the end of the Oppenheimer movie. There's Mrs. Oppenheimer and their 2 kids, Neddermeyer. And the obituary, the official biography. There's a couple things interesting here. You may not be able to read it, so how many of you can't see? I assume in the back you've got no chance, right? Okay, let me read it to you. I'm going to do it quickly. Seth Neddermeyer was born in Richmond, Michigan, 1907, was raised in California. Not true. Why did they put that in there? It's because in that interview I've referred to twice, 4 years before he died, the interviewer said, "Were you raised in Michigan?" Actually, what he said was, "Did you grow up in Michigan?" Neddermeyer intended to tell a joke, and he said, "I never grew up in Michigan." What he meant was, I never matured. I stayed childlike my entire high school career. But the people who read that interview said, well, if he didn't grow up in Michigan, he must have grown up in California. This is his official biography. His research confirmed Niels Bohr's. Niels Bohr was the #2 physicist in the world behind Albert Einstein. Theory, and you'll laugh at this, the absorption of high-energy electrons, Hans Bethe's theory on the large radiative energy losses of electrons in lead. I mean, this is exciting reading, right? Exciting stuff. He helped discover the positron 32, the muon, during World War II. He participated in Robert Oppenheimer's Manhattan Project, advocating the development of the implosion technique, assembling the critical mass of an atomic bomb. Neddermeyer was fired in June of 1944 due to dysfunctionality with his implosion team, and he was replaced by George Genealogical. He worked as an associate professor at the University of Washington at the end of the war, and he was awarded the Enrico Fermi Award in 1982 and died in Seattle in 1988. So the official biography that is government sanctioned and so on and so forth in the scientific world for Neddermeyer. Now, let me close with one thing. In 1 minute, I'm going to tell you how to make an atomic bomb. And this is what Neddermeyer did. You start out, well, let me skip this slide. You start out with beryllium, just a pellet. It's about a 1/4 inch in diameter. And they used to use titanium around it. Now they use graphite. Beryllium around that. So now you got something about the size of a marble. This is the source of the trigger neutrons. This is what sets the thing off. Around that, you put about 15 pounds of plutonium. You could hold it in your hand. It's that small. And that's one of the reasons they worry about somebody bringing a bomb into the U.S. from Iran or who knows where. Surround that with uranium-230. This is the non-radioactive stuff. Use it for projectiles and weights and all that sort of thing. It's a reflector. If the neutrons try to get out of the plutonium, this uranium reflects them back in to make a bigger bang. Around that, you put some boron. Around that, you have thick aluminum. The bomb that was dropped on Nagasaki had steel there instead of aluminum, but today they use aluminum. Then, Seth Neddermeyer's explosive blocks. Explosive lenses. And slow explosive. And I never finished that story. But the idea is, remember those arcs when I was saying the shock wave would come down? Neddermeyer, von Neumann, Kistiakowsky, they did work together on this. We need a fast explosive and then a slow explosive. And I should have gone back to the picture and explained that. I intended to do that. But you've got a slow explosive, you've got a fast explosive, and it ensures that the shock wave hits the plutonium all at once. Just a big crush. And uniform, and everybody said it couldn't be done in that library in 1943. And you put these detonators on there. Each detonator has 2 wires coming in case one fails. You've got redundancy there. You put a steel shell around the whole thing. You hook up some wires. You add some high performance capacitors there. That's where the spark comes to set off all the detonators. Put it in a shell and there's your bomb. And so conceptually, not difficult to do. Getting the rich plutonium, machining it, very tight tolerances have to be held. And this is Tinian Island, the B-29 boxcar that took off to drop the bomb on Nagasaki, took off from there. I have this picture at my house because my dad was asleep right here when it took off, early in the morning of July 9th, 1945. He was on Tinian Island, and there's Neddermeyer again, and so on and so forth. The bomb, the explosion over Nagasaki. So anyway, I'll stop at that point, but hopefully at this point you have an idea why Ursula and I think that Neddermeyer's a pretty impressive guy, and maybe even ought to have a state historical plaque, I don't know where, in the historic village or at the corner of Ridge Street and Main Street. Yeah, so anyway, it's early days on all of that. Okay, questions? And by the way, I was joking with Leo back here. If you want to know how to make an atomic bomb, this is the book that Robert Serber wrote of his lectures in that library. And there's a guy by the name of Richard Rose that wrote what I think is the best story of the making. You can tell I've read this a few times about the atomic bomb. And this, if you want to learn about Neddermeyer in greater detail, this is the book to get. Robert Serber, who wrote this, sort of dishes Neddermeyer. He said the idea for implosion didn't come from Neddermeyer. He calls it television history, because Neddermeyer years ago was on television, isn't it, but movies about him. And he calls it hokum, because he said the real people that suggested implosion were Robert Serber and Richard Tolman. It's not right, but that he wanted to take credit, Robert Serber did, for the success. Serber is one of the guys who said there's no way in the world it can work in that library when they were shouting at each other. So anyway, these books are here if you want to peruse them. But this one, The Making of the Atomic Bomb, Richard Rose, excellent, just outstanding. So, all right. And maybe I didn't mention that we have a Neddermeyer in the room.
Yeah.
Did I say that?
Yeah.
Okay, thank you. All right, good. Good. Yes.
From my limited knowledge in the area, just watching documentaries or whatever, I'm of the impression that if Japan had not surrendered after the Nagasaki bomb, it would have been some time before we would have had enough plutonium for a third.
That was the official thing that was said. I'm going to go into more detail if you want. I'll try to talk 100 miles an hour. But in 1967, they told the truth about a lot of things they were lying out about previously. And then in 1973, they allowed more stuff out. That wasn't really true. That's what the government said, and all the scientists said and all that. They could have had another bomb in about 3 weeks. They were making the plutonium in Hanford, Washington, out in the middle of nowhere. And they were cranking it out at a pretty good clip. That's why it was so critical to figure out how to make a critical mass out of plutonium. If it were uranium, it would have been months before they had enough for a second uranium bomb.
I see.
And even the uranium bomb, now I'm probably going too far into all of that sort of thing. The uranium bomb back then was only 1.7% efficient. What that meant was when they fired those 3 rings over the cylinder, the amount of material that went fissile, that went radioactive, the size of a marble. That's all. The rest of it was blown out of there before it could go. That little marble killed 130,000 people. I don't want to be gross here, but in the first 100th of a second, 40,000 people were vaporized instantaneously. Within the first second, about 75,000 people were dead. In the next 3 seconds, 100,000. And over the next minutes, hours, and days, another 30,000. And just that little bit. And today, the bombs are much, much more efficient. Yeah.
If I could add to that, I used to tell my students when I was teaching social studies and we were talking about the atomic bomb, if you know where I-94 and Ship Road overpass is, if you dropped one of the bombs that they dropped on Japan at the county building, it would have created damage out to that overpass.
Yeah.
Okay, the first mile total destruction, the second mile major, and by the time you got out to the overpass, it'd be relatively minor. The bombs they have today, you drop it on the same place and you got damage in Marysville. Okay, so I just thought I'd throw that in.
Yeah. Just to this is what Ron's talking about here. Because of the light, the bulb's not very bright. This is Nagasaki after the bomb dropped. I mean, a total obliteration. And this is a picture of the bomb going off. There was somebody who was out photographing right at that instant. And all of this was destroyed about a half a second later. And that's what it looked like when it was done. So, yeah. And today, they use atomic bombs to start hydrogen bombs. It's just a trigger. And so we're talking 20,000 pounds. Today we're talking, tons. 20,000 tons of TNT, right? Today we're talking millions of tons of TNT. So yeah, that's why it's a scary thing. Yeah. Any other comments, questions? Yeah.
How many pumpkins did it take to make a pumpkin pie?
If I'm doing it about 57, if some of the ladies are doing it about a half. Yeah. Yeah.
Do we have any idea what Neddermeyer's IQ might have been?
No, he was not a genius though. If there were students here, he was very bright, all right? He was way brighter than the average person, all right? But he was not at the level of the geniuses like Albert Einstein. You know, Albert Einstein's one of the top 6 smartest people ever to live. Oppenheimer was smarter. But after that, Neddermeyer's in that second tier. Yeah.
How deep of the math that these physicists get into? Because they say there is a difference between a mathematician and a physicist.
Yeah.
And, I noticed in your list of people that they had a lot of mathematicians.
Yep.
So what are they trying to coordinate to make sure that they are all on the same page, so to speak?
Yes. Yeah.
You can do a formula, but if the physicist says, I don't like it,
Yeah.
then where do you go?
Yeah.
Or the reverse,
Right. Yeah. There are 2 categories of scientists. Theoretical, Albert Einstein, Robert Oppenheimer. Experimental, Neddermeyer. And a lot, Hans Beatty and Enrico Fermi and Carl Anderson and Robert Millikan. Experimental. These are the pointy heads. These are the geniuses. These are the guys that are really, really, really bright, but not quite at this level. They needed the mathematicians for a lot of reasons. The explosives, the mathematics, to compress that plutonium perfectly, symmetrically. Incredible. Even von Neumann couldn't do the math without a computer to help him out. They had to calculate, you've heard of half-life? They had to calculate lots of things with that. The energy that comes out of plutonium, the energy coming out of uranium, the probability of pre-detonation. In other words, when this bomb is in the B-29, if a neutron came into that airplane from outer space and hit the core, it could have set it off. They were worried about that. Probability, statistics. This book right here has a lot of that, the simple part of the math in it. And, but yeah, they needed it. This was probably this much math and this much engineering construction. Yeah. Yeah.
I think you should have been one of the 30 in the library, but what's your background?
No. I'm way below Neddermeyer.
I agree with you.
I did work near a Nobel Prize winner, my first job. Are you serious about that? What my background is?
We're new in the area, so I don't know if
Okay.
we're supposed to know.
I'm going to talk 100 miles an hour. I grew up on a farm on the west side of Michigan. I was very shy, very introverted, last person that ought to be standing up in front. I didn't want to go to a big school like Michigan State U of M, and I just happened to hear a presentation from Michigan Technological University, small school. So I went up there. And in my freshman year, everybody has an advisor, and the advisor said, what do you want to do for a career? I have no idea. Never thought about it. Why are you here? And so And I just watched a television program of people developing alloys for outer space application. And I told him, if somebody needs a special alloy, I'd like to be able to develop it. So he said, get your bachelor's degree in physics, get your master's degree in metallurgy, get your PhD in applied physics. And that conversation, 5 minutes, I just took his advice and everything worked out from there. I got a job at General Electric's Research and Development Center. When I got there, it was a special program. I really shouldn't have been allowed in the door there. But they did take me, and right across the hall was a guy by the name of Ivor Gaever that won a Nobel Prize in Physics. If you've ever had an MRI, there's a ring in there. You hear the magnets and all that sort of thing. Well, also in there is liquid helium to cool some niobium titanium alloys, and it's a superconductor. He got the Nobel Prize for superconductivity. They start the electricity and it'll go forever until they warm up the helium and so on. Anyway, brilliant people there at that lab, and so I got to see at a distance all of these famous people. And I developed alloys for the nuclear industry, zirconium alloys for nuclear reactors, and then super alloys for jet engines, hard metals for wear parts, titanium alloys for orthopedic things, refractory metals, tungsten, tantalum, niobium, things like that. Do you know what an MRAP is? These armored personnel carriers. Have you ever seen the little domes on those things? They've got radar and sonar and other for all this, that, and the other thing, and they need refractory housings over that. So I worked on that a little bit, and on it goes. So yeah, probably too much, more than you wanted to know. So,
No, thank you.
So yeah, but yeah.
So how did you get to Richmond?
I was out at GE in Schenectady, New York, and I really enjoyed it out there, but my wife and I were from Western Michigan, and my wife and I as well wanted to get closer to family. And GE had a lab here, and so we moved here. And initially to St. Clair Shores, but my wife and I both grew up on farms, liked the farm life, started having kids, and my wife found the place on Low Plank Road out here in Lennox Township. And so
There you go.
that's where we ended up. So, yeah. But teachers, huge impact in my life. So, those of you who were teachers, I think you do a world of good. You may not realize it, but just a simple sentence sometimes will motivate somebody. And so it's worth thinking about. And those of you, we're all older, apart from some people here. What could you do to encourage a younger person to do something worthwhile? Now I'm going to sound like your dad for a minute. In the last few years of my work life, this may sound a little bit arrogant, I hope it doesn't, but the company allowed me to do whatever I wanted to do. And one of the things I decided to do was to go into high schools, particularly South Warren, where I don't mean to be dismissive of anybody or anything or say anything derogatory, but a lot of these kids are coming out of 1 or 0 parent homes. And one of the things I wanted to do was to encourage these kids to think about more than a welfare check and a drug game. And so we'd go in there and we'd say, well, if you can get a high school graduation, a high school degree, here's what you can do, here's how much money you can earn. And then if you get a 2-year degree, here's what you can do, what you can earn if you get a 4, and stuff like that. And you guys can do the same thing. There are people in this area that are lost, kids. They grow up looking at screens. Their only sense of value is how many likes they have. And they think, what purpose do I have in life? And you can encourage those people, just a sentence or two, that's all it takes. And say, look, you have value, you're important to your family, to this community, to yourself. And so, yeah, I'm preaching now.
Just a quick comment. I think most everybody successful can identify a mentor in their life that made a difference. Had it not been for that person, they wouldn't have been successful.
Yeah.
It's kind of just a question, though. In recent news, there was some discussion about reinstituting testing in terms of gun violence. It's been idle for the last several decades. So I was just wondering what your professional opinion is relative to reinstituting the testing.
Yeah, all right. When I start talking politics, my opinion is no better than anybody else's, all right? We all have our own background and the things that influence us and so forth. I never know when the president speaks, and I admire him in a lot of ways. I wouldn't want him as my next door neighbor. But I don't know what's bluff and what's serious. When he says something, he follows through often enough that everybody's, real careful. But there are other countries that are testing things that first of all, the government knows this much, we know this much, all right? And I think what Trump is saying is if other people are going to do it, we're going to do it too. And I think he's trying to screw with Putin. And anyway, so do they need to test? Probably not, because they have computers that can model all of this stuff. So yeah.
Okay, thank you.
Yeah.
I got it.
But again, my opinion is no more valuable than anybody else's on stuff like that.
I'm in agreement.
All right, I am in no hurry to leave. Thank you very much for coming.